All right, so let's get started. Let's look at how to find the surface area of a sphere. Now notice a sphere we talked about is a three-dimensional object. So we can't just talk about the flat area. Like if you were painting a wall or coloring on a page, those are two-dimensional objects. So you could just talk about a flat area. Surface area means the surface all the way around the sphere. So like if you had a basketball and you could peel off all of the leather and all of the seams that covered the basketball and then measure the area of those would be the surface area, right? Makes sense, the area of the surface. Okay, so hopefully you can kind of picture that. The way that we find the surface area of a sphere, again, we have a formula. If you'll remember, the area of a circle, which is like the two-dimensional cousin to the sphere, is pi r squared. The surface area, so if we make that three-dimensional, it's going to be 4 pi r squared. We're going to quadruple it, okay? So remember that formula, it's going to come in really handy. We need that to solve these problems. All right, first one, example 3. You are decorating the Christmas tree and you want to paint some of the ornaments. You know the radius is 1.5 inches, find the surface area. Okay, so if we're going to paint these ornaments, we need to figure out how much paint we need to cover the area or cover the outside of the ornament. So we're looking for surface area. We know the radius is 1.5 inches, so let's see if we can use our formula to figure out the surface area. We're going to use SA for surface area. Our formula says 4 pi. Do we know our radius? Yes, we do. It's 1.5 inches. So 4 times pi times 1.5 squared. Let's check that out on our calculators. The surface area, let's round to 2 decimal places, just like we do in class. 28.27. Check my work, make sure I'm right. 28.27. 28.27 what? Inches? Meters? Feet? Well, our radius is in inches, but remember we squared our radius, so our surface area is actually going to be inches squared. Just like when we work with the area of a circle, we always end up with inches squared or feet squared or meters squared or whatever. Same thing with surface area. We're going to end up with a unit squared. All right, let's try another one. All right, example 4. A little bit different, but we're still going to be working with that same formula for surface area. So this time, we're talking about a tomato. It says the surface area of a tomato that you picked from your garden is approximately 201 centimeters squared. Find the approximate radius. Okay, so last time, if you remember, they gave me the radius. They wanted me to find the surface area. Now they're flipping it, okay? Same kind of process, we're just looking for a different variable here. So we know that the surface area is 201 centimeters squared. Let's start with our formula. Surface area equals, remember it, 4 pi r squared. Let's plug in what we know. We know surface area. So we're going to plug in 201 for the surface area equals 4 pi r squared. Now remember, pi is just a number. It's just a symbol that stands for a number. It's 3.14 repeating. So we can divide by pi because it's a number, and we can also divide by 4 to both sides. Here we're going to end up with just 1 r squared, or r squared. Take your calculator and divide 201 by 4 times pi. Make sure that you put 4 pi in parentheses. And I'm getting 15.995071, blah, 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 but again, we'll round to 2. Okay, we haven't really seen these very often. R squared equals something. I want to just know R. I don't want to know R squared. So think about, how could I reverse squaring a number? Or what is the inverse operation of squaring something or taking something to the second power? If you said taking the square root, you are correct. If I take the square root of R squared, I'm just going to end up with R. And likewise, I'm going to have to take the square root of 15.99507.178, whatever you got on your calculator. Okay, go ahead and calculate that. If we round that, I'm getting an answer of 3.999383925 on my calculator. If I round that, that's going to round up to approximately 4. Because that 0.999 is going to push me up to 4. So my radius is going to be 4 centimeters. Okay, now notice that the problem, when they talked about the surface area, they said it was approximately 201 centimeters squared. And then they wanted me to find the approximate radius. So maybe I should change these two approximations there. Think about, why do you think they said approximate in this problem and not in the problem with the ornaments or the problem with the earth or the tennis ball? If you said that it's because a tomato is not a perfect sphere, you're right. A tomato can have lumps, and it can be bigger on one side than the other, or it could be longer or shorter or whatever. It's not, tomatoes are very, 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 very seldom going to be like a perfect circle or a perfect sphere. They're not really going to come in the shape of a ball. They're going to have little lumps and stuff. So that's why they're saying approximate the radius. It's approximately 201 centimeters squared. All right, we just have volume left.